there, ROS developers around the world, and welcome to a new open class. Today we are going to continue with our topic of how ChatGPT can help us program robots faster. So it's going to be another very interesting class. And today we are going to focus on our robot racing contest, which is a super interesting contest that we are hosting during this month of July. So I will explain a bit more during the beginning of the class now, in case that you are not familiar with it. Probably others you already know about it. But yeah, so today we are going to use ChatGPT to help us see if we can, I don't know, maybe win this robot racing challenge. So yeah, we'll see. Then first of all, as always, let me know if everything is working fine, if sound is fine, video is fine. Let me know here in the chat so that we can continue with the class without any issue. So yeah, I'm going to be checking right now here your messages. So yeah, let's already get started. Then I'm going to switch right now to my computer screen. There we go. So so yeah, hello to Nilofar, Fernando, Harsh Gupta, Sajat. So it is fine, everything is fine, everything fine. Okay, great. So it seems that everything is working properly, so we are good to go. Then one more time, welcome everybody. In case that you are already veterans of these open classes, then you already know what you do, what you have to do now. In case that you are new to our open classes, let me just very quickly introduce you. So our classes are practice-based classes. They are also interactive. So meanwhile, I'm going to be explaining here and showing different demonstrations. All of you from your home can replicate basically everything that I'm going to be doing. And you should actually do that. Yes, so you should not only be listening and watching to what I am saying, what I am doing, but you should be doing it yourselves. Yeah, that is the way that you are going to get the most out of this open class. So in order to do so, we always prepare ROSJECTs for our classes, which are basically self-contained ROS projects that can be very easily shareable and open it just with a web browser. You don't need to set up, install anything in your computer, okay? Then how can you get the ROSJECT for today's class? Very easy. All you have to do is to click on this button that appears right here above the chat, which says fork, and open the class ROSJECT. Yeah, I'm going to do it myself. So let me click here, and then as you click in the button, you are going to be automatically redirected here to the main ROSJECT page, which is this one here. Okay, you also are going to have here in the right side the streaming panel, as I like to call, with the live video here, also the chat in case that you want to type your questions, your comments, whatever. Right? I'm going to, in my case, I'm going to just remove this from my ROSJECT and put it in a different window, because actually I would like to have more space so that you can visualize everything in my ROSJECT better. All right. All right. Then yeah. So meanwhile, this is going to take a few seconds, maybe 1 minute. There you go, to fully load. Then once everything loads, you are going to get something similar to this. Okay. First of all, you are going to have the notebook for the class automatically opened right here. Yeah, this is the notebook that we are going to be following. I have prepared for this class, right? So this contains everything that we are going to be covering and doing today. All right. So this is the notebook. Very important to have it. Now, also automatically, you are going to have the simulation open, which is going to look something like this. Right, very cool simulation, as you can see, with our fastbot robot here and this Mario Kart themed racing track that we have here, and that we are going to use for today's class. Yeah, so yeah, we are going to go with this in a moment. And yeah, so also finally, another thing that probably is going to appear for you is a terminal, right? It's going to automatically open, and it's going to start automatically running a couple of commands. Don't worry, this is normal, because this is basically automatically installing some specific dependencies that we need for this class. All right? Then, yeah, so with this, you are set up with the ROSJECT. So make sure, please, that all of you are in the same stage as I am. Everybody has copied the ROSJECT, and everybody is ready with the notebook opened, and also the simulation here opened, okay? Yeah, so please let me know in the chat if everybody is ready. And meanwhile, let me also tell you that this ROSJECT that we are going to be using for today, by clicking on this for can open the class ROSJECT button, you also have created a permanent copy in your account, right? What does this mean? This means basically that whenever you come to the Construct account, you can come here in the left side menu to the My ROSJECTs section, which is right here, right? Let me open it in a moment, yeah? And then you are going to have a copy of this ROSJECT, as you can see here, in your account basically forever, right? So not only for today's class, but if you want to work on this specific ROSJECT tomorrow, next week, next month, whenever you want, you are going to have access to this ROSJECT from your account. All right? So let me see if everybody is ready. I am ready, says Sajat. Anderson Nardin is asking, does the simulation have an ambient sound? That's a very convenient question. And the answer is yes, okay? So mine here is muted, but probably you have noticed that the simulation has ambient sound, okay? Don't worry, because if you want to deactivate it, to turn off the sound, it's very easy. All you have to do is to click here on the simulation screen, okay? You click here and then press capital T, all right? If you press capital T, this is going to deactivate the sound, okay? You have the letters here, audio, press T to toggle, okay? My robot here is about to fall, but not a problem. I will restart it in a moment, okay? So yeah, basically with the capital T letter, yeah, you have to click on the simulation window and then press T to activate or deactivate the sound, okay? As you prefer. Now probably it would be better if you deactivate it, because I'm going to be talking also, so maybe it's going to mix a little bit both sounds. All right? So yeah, let me know. Okay, how to mute sound in simulator. I have already answered to that. So besides this, is everybody ready with the ROSJECT loaded? With the simulation loaded, simulation muted also? Everybody's ready? Let's go. Okay, so yeah, then let's get started. All right. So, yeah, then basically the topic for today's class, as I already said at the beginning, is can ChatGPT help you win? Win what? Well, in this case, it's the robot racing contest, okay, which is a contest that, as I said, we are hosting during July, and which is based on this Mario Kart simulation, where basically you have to complete a lap in the fastest time possible, okay? Yeah, but I will get back to this in a moment. First of all, let me just explain you a little bit about the simulation, all right, so that everybody's familiar. I have already explained to you how to mute, unmute, yeah, but basically now you can see that my simulation is kind of falling, the robot is kind of falling, okay? So whenever you want to restart the simulation, all you have to do is to close it, for example, and then click again on this icon that is in the bottom menu here. Yeah, you click on this icon, and then this is going to basically restart the whole simulation. Okay, you will see now that this gets loaded again. There we go. Okay, so now how to interact with the simulation? Well, basically there are a couple of things that you can do. One, as you have already experienced, is to switch on and off the sound with the capital T. All right, so let me do that myself. Remember that always when you want to interact with the simulation, you have to click on the simulation window, okay, to set the focus on the simulation. Then also, you can use the arrow keys from your keyboard to move the robot around. So you click onto the simulation, and then using the arrows from your keyboard, you can move the robot forward, turn around, and control it through this lap. Okay, you can try to drive it a little bit through the racing track. Yeah, it's quite fun actually. So, so yeah, this is just by clicking on the simulation window and then pressing and controlling the robot with your keyboard arrow keys. Okay, there you go. Okay, and then another thing that you can do is basically, for example, with the capital R, you can see it here also from the letters in the simulation, is to show the laser beams. Okay, let me show that in a moment. I have just pressed the R, and this, maybe it's going to take a bit, and there you go. This way you can see all the, visualize basically the laser rays from the robot, okay? And again, to deactivate it, just press again the R, okay? And there we go. So this is how you can interact with this simulation directly working from the simulation, okay? Now, of course, this class is going to be based on ROS, okay? So obviously, you can also interact with this simulation using ROS topics and all the typical ROS tools, such as, for example, RVs. Yeah, so here you have how to visualize data from the robot using RVs. You can use this command, which is going to start RVs with a predefined configuration file that I have already prepared for you. Yeah, so in order to check this, all you have to do is to copy and paste this command into a terminal, right? So for example, I'm going to copy and paste it directly into this terminal here, right? And then this is going to open RV's application with this config file that already has a couple of things prepared, like the robot model, laser visualization, also the camera. Yeah. So once you execute that command, after a few seconds, you are going to have a window like this one. This is the graphical tools window appear. Yeah. And ideally, you are going to be able to see it directly. If not, maybe you are going to get this message which says disconnected. Don't worry, just click on reconnect and everything is going to load properly. Okay, so there you go. Here I can see my robot with the camera. Here I can see what the camera is, the robot's camera is seeing right now. And these points that you can see here are the laser, the LiDAR detections. Okay, you can see that they have the shape basically of the racing track, right? And yeah, so you can move the robot around, and you will see how the camera changes, the laser also changes, and so on. Okay? Yeah, so typical RV's experience, right? What else? Okay, so the last thing I want to show you so that you know how to properly interact with the simulation is obviously you can run a ROS to topic list to list all the available topics that the simulation provides. Yeah, here you can see the common belt topic, for example, camera-related topics, odometry, laser, etc. Okay? And finally, obviously, you can also use the very well-known teleop twist keyboard program from ROS in order to teleoperate the robot using your keyboard. Yeah, this is the very well-known ROS program to control robots, to send velocities to mobile robots using your keyboard keys. All right, and in this case specifically, you can see that we need to remap the common belt topic to the specific topic that our robot uses, which is fastbot1 command bell. Yeah. So basically, let me also copy and paste this command here into the terminal, and then with this, let me put the simulation here at one side. Obviously, you can use it to, again, control the robot velocity, as you can see right now, using the keyboard and using, in this case, directly ROS ROS topics, right? I am sending velocities to the robot and moving it around. Okay, as you can see, the camera basically follows the robot as you move it, right? But still you can also change the orientation of the camera. Like for example, here I'm going to change to be behind the robot, right? And then now, as I move the robot, I'm going to be following it, okay? So you can still also change the point of view of the camera, right? So, yeah, there you go. And with this, you can start already playing a little bit with the robot. So let me stop it right here. And yeah, so far so good. Yeah, is it clear? Everybody is able to properly interact with the FastBot simulation? Yes. Let me have a look at your comments. Here, Emildo is asking, will we have access to a recording of this class? Yes. As always, we always publish the recording of the classes, okay? Usually 24 hours after the class, you are going to be able to find the recording in our YouTube channel, the Construct YouTube channel. So yes. So far so good, says Sajat. Nilofar also says yes. So, Alexi says, my teleop, not React. Maybe because simulation in another window. Yeah, so for using this teleop program, you need to have the focus in the terminal, okay? Not in the simulation now, but in the terminal, okay? So now with the focus in this terminal, yeah, you just press the key, okay? In this case, it's not the arrows keys, okay? So this is different. So if you click in the simulation window, you can control the robot with the arrow keys, okay? If you use the teleop program from ROS, then the keys that you have to use are others, yeah? For example, in this case, the I key is forward. So if I press here the I key, the robot moves forward, right? Okay. Yeah, for example, J and L are for rotating the robot. The letter K is for completely stopping the robot. Comma is for moving backwards, okay? So keep in mind this. When you use the ROS teleop program, then the keys that you need to use to move around are the ones displayed here in the program, okay? All right, so let me keep going. Okay, so yes. Then also just remind you that the robot that you are using here in this simulation is the FastBot robot, which is our own robot that we have designed from the Construct. And it's very interesting for many purposes. You can use it for your own ROS projects. You can use it for practicing, for learning yourself, or for even teaching ROS to others. Yeah, it's very convenient for being able to work both in simulation and in a real environment, okay? So here I leave you the information and also a link in case that you would be interested in getting your own FastBot robot, which is ideal for learning, for teaching, basically for working with ROS, and for testing your ROS projects with a real robot. Yeah, also getting all this grasp of how it feels to work with a real robot. Yeah. Okay, then we are ready to get started. Okay, so today we are going to continue, as I already said earlier, in the same line as last week. So this is basically how we can use ChatGPT, right, to help us in programming robots faster. Okay, so I'm not going to go over all these again, but basically, probably all of you already know what is ChatGPT, right? And how ChatGPT can help in robotics. Something that we were discussing last week, in last week's class, and I think it's very interesting, is that ChatGPT cannot do everything for you. All right, what does this mean? This means that in order to be able to properly use ChatGPT, you need to have a basic knowledge, at least, okay? So you cannot basically ask ChatGPT to do everything for you, all right? You need to have the knowledge, right? You need to know what you want to do, and then with that in mind, you can use ChatGPT to take care of the lower level things, okay? We already demonstrated this last week. We are going to demonstrate it again this week, okay? But I want to clarify this, okay? So you, as a robotics engineer, you need to have a good understanding of robotics, of ROS, right? So that you can work on a higher level of abstraction and then use ChatGPT to basically optimize, right? And allow you to get all the low-level stuff much faster, like creating the code, right? Things that you don't really need to remember by heart, right? And you can rely all that kind of work to be done with ChatGPT, okay? Yeah? So this is an important point that also we were discussing about this last week, and I wanted to also point it out today, okay? So you still need to have an understanding of what is ROS, right? And robotics, of course, right? And so you cannot just know absolutely nothing about ROS or robotics and then ask GPT to do everything for you, okay? That is not going to work, and it's going to be a complete disaster, okay? So ChatGPT is a tool that you use to be more efficient, yeah? To be able to have things done faster, okay? It's not a tool that you use to do all the work for you, okay? Yeah, this is an important point, and I want to clarify it before we getting started. And how it can be useful then. So, for example, things as reducing time spent on boilerplate and repetitive code, for example. Yeah, also acting as a real-time assistant when you're stuck. Yeah, helping you solve problems. Yeah, you are dealing with problems and you are stuck with that. ChatGPT can be a great assistant in helping you try different solutions, having different points of view, right? Also, it can help you think through problems step by step. Okay, we are going to follow now one step-by-step method to get our program done, and allowing you to focus on high-level logic. Okay, this is what I was saying right now. Yes, so ChatGPT can help you focus on the high-level logic, right? Which is where your robotics engineer knowledge is going to be most useful. Yeah. And then allow ChatGPT to handle the syntax, the low-level logic, low-level stuff. Okay? Yeah? And then just also I want I already shared this last week, but I want to have it also in this week's ROSJECT so that in case there's someone new, you also can have access to this. Okay? So some tips on creating good prompts for ChatGPT, okay? Prompts are very important, and prompts really matter. Yeah, if you want to take advantage of ChatGPT and take the most out of it, you need to write good prompts because they do make a difference, okay? Yeah, and here you have some tips, like for example, be clear about your goal. Yeah, what do you want to achieve? What do you want to do? You have to be clear, all right? Provide context when possible. Yeah, also very important. Like for example, when asking about errors, very important to provide the context of that error. Yeah, what is the code you are trying to run? What is the error message that you are getting? All this kind of stuff. Also, it's very important. It's going to help ChatGPT to help you better. Okay. Also, be iterative. Okay, this means that basically treat ChatGPT as a conversation. Okay. Yeah, so you can start asking ChatGPT on a higher level of abstraction, and then continue as if it was a conversation, asking subsequent questions, okay? And this is also what we are going to demonstrate and to do in today's class, okay? Yeah, so some tips to writing good prompts for ChatGPT. All right, yeah? And then finally, just before we actually get started with the practice, just a very quick introduction to the robot racing contest, yeah? So the robot racing contest is basically a simulation-based contest. It's based on this simulation. Okay, let me, yeah, this simulation, you can see this very cool racing track, which is based on the Mario Kart video games, yeah? And then basically the purpose, right, is to create code so that the robot is able to complete a full lap to this racing track, to this circuit, okay? And the goal is to complete the lap in the lowest, right, the fastest time. How you do it is up to you, okay? Then I have, you have more information here in this link down below, right? So you can get more details about the competition, but basically how to participate is by getting a copy of this ROSJECT, okay? So you are going to be working on a different ROSJECT, not this one, yeah? There is a specific ROSJECT for this contest, yeah? And then inside that ROSJECT, you are going to create your project to build your program, and you can use any tech you like, okay? So you are not limited to something specific. You can solve this contest, this challenge, how you prefer. You can use, I don't know, AI techniques, reinforcement learning, navigation, perception, anything that you like, you can use it, okay? That is completely up to you, all right? And then once you are done, once you have completed your code and it's working, then you send it to the following email here. And the deadline is July 28, okay? So this is the robot racing contest. And also, by the way, let me also remind the prize, okay? So the winner, which is going to be decided by the end of July in a live event, the winner is going to get a real ROS2 robot, like the one that I have here. Let me show it to you here with the full camera. Yeah, it's going to, oh, it's green, so you cannot see it very well. But yeah, basically, you are going to win a robot like this one, all right? A mobile robot with a LiDAR, a camera, etc. For you, for being able to continue practicing your robotics and ROS knowledge, okay? So super cool prize for the winner of this contest. Then what are we going to do today, in today's class? Okay, so in today's class we are going to use ChatGPT to help us to help us generate a solution for this contest, okay? Yeah, so I want to participate in this contest. How am I going to do it? Okay, then this is what I'm going to be doing today, yeah? I'm going to be using ChatGPT to help me create a solution for this contest, right? So, so that I can generate, as fast as possible, some code in order to make the robot complete a lap to the circuit, okay? So this is what we are going to be doing today. So, yeah, we are ready to get started. Then before we go into the meat and bones of the class, any questions, comments so far? Let me have a quick look here at the chat. Nice prize, says Emildo. Sure. So a very cool robot that you are going to get for free if you win the contest. The robot uses invisible technology, says Anderson. Yes, kind of. Yeah. All right. So are we good to go? Yes. I cannot share the ROSJECT. It says the ROSJECT is private. You don't have to share any ROSJECT yet, Sajat. So I don't know what ROSJECT you are trying to share, but you don't need to share any ROSJECT right now, okay? All right, so let's get started then. Okay, then, yeah, so how can we use ChatGPT in order to help us find a possible solution for this contest, okay? So we are going to start by the first step, which basically is to have or to figure out a high-level idea of what we want to do, okay? Yeah, so in this case, obviously, we want to solve the contest, right? So our goal on a high level of abstraction is to complete a full lap to the racetrack with our robot, right? Okay? Then, as I already mentioned, there are many ways in which we could achieve this, okay? But for this class, we are going to use a perception approach, a perception-based approach, okay? Yeah. Then the high-level idea or the high-level goal is to make the robot complete a full lap, right, to this racing track. This is our high-level idea, high-level goal. So what do we need in order to achieve this? We need three main things, right? We need a ROS2 node, which in this case is going to be written in Python, okay? Because we want to use ROS2 for this solution. So we need a ROS2 node. We need to be able to move the robot, right? Without moving the robot, it's going to be impossible to make it complete a lap to the robot, right? And we need to use perception. In this case, what we are going to do is to detect the racing track, okay? Right? So on a higher level, I know that I can use perception to detect the racing track and use some other technique or some other control, right, to detect where the racing track is and follow it. Okay? Yeah, so what I'm going to need on a high level are these three things: a ROS2 node, move the robot, and detect the racing track. Okay? Here we are on a higher level still. Okay? Later we will go into more details. Okay? Then this is step one. Step one is clear and is complete. Let's go to step two. Now what we are going to do is to create a boilerplate. Okay? So here we are going to create a basic class, a basic node, right? So that we can have a basic structure for our final code. Okay? Then here we are going to basically start generating the first prompt for ChatGPT and providing a little bit more of detail, okay? Because remember, hint number one to write a good prompt for ChatGPT is be clear about your goal, okay? So this is the prompt that we are going to use. Create a ROS2 node in Python that does the following. Defines a publisher to send twist messages to a topic named fastbot1 command bell, okay? To a topic named fastbot1 command bell. Yeah, so see how I am specifying that I want a ROS2 node in Python. I want to publish twist messages, okay, because I know that for sending velocities to a robot, I need to use twist messages. And I also know the topic where I should publish, which is fastbot1 command bell. Yeah, all this information, I have it, right? So I am providing it already to ChatGPT, yeah? Then also it defines a subscriber to a topic named fastbot1 camera image raw that uses image messages, okay? I know that I'm going to be using the camera data for my perception logic, yeah? So I asked ChatGPT to subscribe to the camera topic, right? And then finally, I have another request, which is in the camera callback, display the images, captured by the camera using OpenCV. Okay? So this is the prompt that the first prompt that I'm going to send to ChatGPT in order to generate my initial structure of the code. Okay? And as you can see, I am clear about what I want and providing details about topic names, messages, these kind of details that I already know. I am providing them so that the result is going to be much more accurate, right? Define a result. Then here I have the provided code, which I got using this prompt during my previous test, right? When I was preparing this class, basically. But now we are going to do everything live from zero, okay? So I'm going to copy this prompt directly here from the notebook. Let me do it, copy. And then I have a ChatGPT, a new session right here prepared. So I'm going to paste my prompt to ChatGPT. There we go. And send. Okay. And then here we can see the response and the code that ChatGPT is generating for us live. Okay? Okay, then we are going to be using this code directly, of course, right? Then for that, we need to create a package, okay? So that's the next thing we are going to do, to create a new ROS2 package, okay? We could ask also ChatGPT to create the package and everything, but I already did that in the previous class, so we are going to skip that for now, okay? Then to create a new package, we just go to the ROS2 workspace SRC, right? And then here you are going to see that there is a PNG image, okay? We are going to use it later, so don't mind about this. Then here just let's create a new package, ROS2 package. By the way, in case, okay, I already know the command, but maybe some of you out there don't remember the command. And that is normal, okay? You don't need to remember exactly how is the command to create a ROS2 package, okay? That's not important or relevant for robotics, yeah? That's not where your knowledge as a robotics engineer should focus, okay? It doesn't matter what the specific syntax is to create a ROS2 package, right? That's not really important for robotics. So all that kind of stuff is what you can rely on ChatGPT to assist you with, okay? So in case I'm going to do it, for example, here, so give me the command to create a new ROS2 package for Python, okay? There you go. So here I have the command. I don't need to remember, okay? It's not important. I don't care. Just use the command directly from ChatGPT. Okay, then copy paste, and I'm going to name my package. Obviously, I need to change here the package name by, I don't know, I'm going to name it follow track, for example. I need to change my keyword here to Spanish. Follow underscore track, okay? There you go. And like this, I have created my new ROS2 package, follow underscore track, okay? So at this point, let's all open the code editor. To open the code editor, it's the second icon that you can find here in the bottom menu, yeah, which says code editor if you hover over it. Yeah, so just click there, and this is going to automatically open the code editor right here, okay? And then this is going to give you access through a graphical tool, which is always easier to manage, right? To all the different workspaces, files, everything in this project. So in this case, inside the ROS2 workspace SRC, we have our new follow track ROS2 package, okay? And then inside the follow track, we are going to generate, we're going to paste directly the code that ChatGPT has generated for us. Okay, it was here. Here it is the code, okay? So then, for example, I'm going to name my code as Okay, there we go. So here I'm going to generate the new Python file. So so for example, I don't know, follow.py, okay, or class. Let me name it class. Class.py. Okay, actually, let me name it open class.py. Okay, this is going to be the name of my Python script. Okay, and then inside my Python script, I'm going to copy directly the code from ChatGPT and paste it in here. Paste. There we go. Okay. Then what do I need to do next? Well, next, what I should do is to test the program, right? Okay, so very cool. ChatGPT has generated the program that I have requested from him, but does this actually work? So we should test it, and then for that we need to compile it, right? Okay, so we need to compile the code before we are able to test it. For that, we need to update the setup.py, okay? These steps are steps that I already followed and include and actually used ChatGPT to complete in the previous class, okay? So I have not included all these information in the notebook, but yeah, this is the kind of stuff that we can use ChatGPT for, yeah? So I know that in order to generate an executable from my Python file, I need to add some lines here to the setup.py file of my package, right? But I don't remember exactly what it is. So let me ask ChatGPT again. Give me the lines I need to add to console scripts in the setup.py file in order to generate an executable, for example. Okay, this is just a prompt that I am generating now on the fly. Okay, and there you go. So I don't remember exactly what I need to put, so I asked ChatGPT for that as a conversation. Okay, see. So yeah, exactly here I have exactly the lines that I need to use, with even an explanation in case that I need it. All right. So I'm just going to copy directly from ChatGPT response here, and then there we go. Yeah. So here, in case that you are not familiar with what is what, you have the explanation right here. Okay. So for example, the first part is the name of the executable. This fastbox controller is the name of the package. This is the name of the Python script. Yeah. So all this information you have it here in case that you don't remember. So yeah, how we are going to name our executable? So for example, open class _node. Yeah. The name of our package in this case is follow_track, right? And the name of my Python script is open class. Okay, so executable name, package name, Python script name. Okay, with this I can generate generate my executable, right? So then let me compile my workspace in order to generate the executable, and then I can test it with directly ROS to run, for example, ROS to run, follow track, ROS to run. Oh, wait, let me source. I forgot to source. Important. So ROS to run, follow track, and then our open class node. Okay. So open class node. There we go. Okay. So my node is running. Then ideally, there we go. I am getting here the feed of the live feed of the camera, right? What the camera is capturing right now. Okay. Then, because the camera resolution of this specific robot in the simulation is not very high, then the resulting image that I get here in the display also is not very big. Okay. So another thing that we can do, for example, is ask ChatGPT to make the display bigger. Okay. So can you make the camera display bigger, it's very small. It's very small, for example. Okay, so here he's giving me some information of how to do it. I'm going to tell him to directly add it to the camera callback. Add it to the camera callback from the previous code. In the previous code. Okay? There you go. So now it's going to generate my callback with the resizing thing. So all I'm going to do is to copy it directly again here from ChatGPT and paste it to my callback, which I have right here. So let me do that right now. Okay, in this case, I need to fix here the indentation of the code, and that's it. Okay, so let me recompile my code very quickly. We are running here. Let's have a look at the display, and now it is much bigger, so we can see better what's going on, right? So let me move the robot actually a little bit here, and we will see how indeed this is the live feed of the camera. Yeah, as I move the robot around the circuit. Let me, for example, go down here. Let me change a little bit the camera. Get a bit closer. There we go. Okay. Yeah. No, I need to go like this. There we go. Okay. Yeah. So basically, I can see that this is the code that ChatGPT has generated, and it's doing what I asked it to do. Yeah. So my code, let's quickly review it. Basically, is let's go back to the prompt that I used, which is here. Yeah. It defines a publisher to send twist messages to a topic named fastbot command bell. We are not using this yet, okay, we will do in a moment, but we can see that our code has this publisher defined precisely, okay? It also has the subscriber defined here for the camera topic, right? And in the camera callback, we are displaying the images captured by the camera using OpenCV, okay? All this, it's being done, and furthermore, we are also resizing the image, okay? Then, is it important for us as robotics developers to know that in order to resize a CV display, we need to use this line of code and use the resize method, yeah, with these specific attributes, etc.? Is this important or relevant for us as robotics engineers? I don't think so, personally. Okay, I think that there are other things that are more important for us and that we should dedicate the time to, instead of just reminding the syntax of some specific code. Okay? Yeah, I think it's much, we as roboticists, we are much more useful working on a higher level. Okay? Yeah? So this is why ChatGPT can be very useful in helping us deal with all this low-level stuff. Okay? Yeah, does it make sense so far? Okay, are you guys following? So let me have a quick look at the chat to see how you are doing. Does this make sense? So far? Yeah, sure. Says Anderson. Okay. All right. So then I guess I'm going to continue. Okay. So, yeah, let's continue then. All right. So what else? What else? We have completed step 2, right? Which is create a boilerplate, okay? And starting code that we can use, all right? So what is the next step? Well, the next step is to continue to complete the details of our implementation, okay? So in our case, what's going to be the details? All right, so now is when we need to start getting more specific, okay? So I am able to capture the images from the camera, right? So what am I going to do with my robot? Yeah, what is the logic I'm going to use in my perception, right? In order to be able to successfully complete the racing track, okay? Here, there are a couple of possibilities. One is that you have one implementation very clear, and then you can ask that directly to ChatGPT, for example, okay? But you can also ask ChatGPT for assistance in what to do, okay? So, for example, this is a prompt that you could use in this scenario, right? So, my goal is to use the camera from the robot in order to detect the track and follow it, okay? This is a very high-level idea. Yeah, I'm not giving much details. Actually, I'm not giving details at all about the implementation, yeah? I just know that I want to detect somehow the track and follow it with my robot, yeah? Then I asked ChatGPT, what perception techniques could I use for this? So this is a prompt that we could use, okay? Then I'm going to use this prompt, for example, directly here, yeah? And this could be a way of using ChatGPT as an assistant, right? For example, this is a demonstration of here. Yeah. So so using ChatGPT as a real-time assistant when you are stuck. Yeah. I am not clear of what technique to use, so I'm going to ask GPT what possibilities I have. Yeah. And then ChatGPT is going to send several possibilities that we can use, right, in order to do what we want to do, which is detecting the track and following it. Yeah. For example, number 1, color filtering, thresholding. Okay. Number 2, region of interests. Yeah. Contour detection or moments, edge detection, and huge transform. These are many different implementations related to perception, okay, that I could use in order to implement my high-level idea, which is to detect the racing track and follow it, okay? So in our example, we are going to go with option number 1, which is color filtering thresholding, okay? So the very first option that ChatGPT gives us is a very valid one. Yeah. In this case, this is if the track has a distinct color, for example, white, yellow, or black. Yeah. We can convert the image to HSV color space, apply color thresholding to isolate the track, and then use morphological operations to clean up noise. Tools for this OpenCV. Okay. And feed into a control agreement. Here's a practical breakdown of techniques you can use. Okay. Yeah? Okay. Then, for example, yeah, a follow-up question, okay, would be to, okay, so I have one implementation clear. Well, in this case, in the example, this is the answer that it gave me, okay, during my tests, which is very similar, yeah. So option 1 was color thresholding segmentation. It's same to convert image to HSV and use the CV2 in range to isolate the track color, okay? In this case here, what we are doing, here there are 2 extra steps, which is to find the shape of the track and use a centroid to follow it, okay? In this case, this is a combination of several options that it gave me here, yeah? Here I have the color filtering and thresholding. Here I have the contour detection, and down here I had the centroid, okay? Yeah, so in this case we are going to do a combination of several options from here, okay? But this is where your high-level knowledge as robotics engineer should kick in. okay? Yeah, if you have no idea of what you are doing, you are not going to understand anything of what ChatGPT is saying here, okay? So this is a very good example of showing why you need to have an idea, right, of what you are doing, okay? Because you cannot rely completely in ChatGPT for everything, yeah, but it can be a very good assistant for this kind of stuff, yeah? But at some moment you are going to have to step in to basically interpret the data information that ChatGPT is giving to you, all right? So what are we going to do here? Okay, then I have some ideas of what I can use for achieving my goal, which is to detect the track and follow it, right? Yeah, my high-level goal. I have some more information now from ChatGPT, so I'm going to be more specific. So the follow-up prompt that I'm going to use is this one. Update the camera callback so that it can detect the track by isolating the track color and find the track contours, okay? Then compute the track centroid. Finally, display the resulting image with the detected track and the centroid, okay? So this is a combination of everything that ChatGPT is saying, for example, here in this case, in this first option, yeah? To detect the track by isolating the color, yeah? Then detect the shape, find the contours and find the shape of the track, and then compute the centroid of the track, okay? So this is a combination of all the different things that ChatGPT gave me here, in this case in option 1, and here is a combination of different options, a little bit of one to find to isolate the track, yeah, using HSV colors, and also to find the contours to get the shape of the track, and finally get the centroid, okay? To use a controller to follow the centroid in the track. Okay, then let's use this prompt directly again from here and paste it to ChatGPT. All right. Okay, so convert ROS image to OpenCV, convert image to HSV color space, apply color thresholding to isolate the track, find contours of the track, compute the centroid, draws the contour and centroid in the image, and displays the final result. Yeah? This is exactly what I have asked ChatGPT to do, and this is the updated callback that ChatGPT is providing to me. So I'm going to get directly this and paste it to my code. Okay? Do I need to fix? Yes. I don't need to fix the indentation. So let me do that. And save. Okay. Right. So here you can, if you want, analyze the code more in depth, but basically this is all the CV methods and CV syntax, okay, required for achieving what I am asking here on a higher level. Okay, then what I'm going to do is to straight go to testing this code. Okay, I want to see if what ChatGPT has provided me is good or not, right? So I'm going to compile my code, of course, source, and then run the node. Okay. Okay, so here I have the node running. This is what the camera is capturing, and I can see some things appearing here in the left side, okay? So it's not working as intended, okay? Then any idea of what is happening here? Does somebody know what is happening in my example here? Okay, because it's not exactly working as I intended, right? My idea would be that the track is detected, and I compute and I get the centroid of the track. Yeah, but here I'm getting some random detections there in the left side. So any idea, any suggestions of what is going on here? I'm reading the chat. Anybody? What do you think is going on here? For this, probably a little bit of knowledge on robotics, on perception, more specifically in this case, is required, okay? Here, Fernando says no idea. Anderson says track bar color values are not well adjusted. Maybe the thresholds are wrong. Very good, very good. Sasha and Anderson are on the good line of thought, okay? Also, TMND here says filters, the wrong color, wrong threshold. Okay, very well, very well, very well. So, see, if you have a knowledge of robotics, of perception, you can kind of guess, yes, or have an idea of what is going on, why this is not working, yeah? So basically, we can see here from our color, yeah, that we have a lower and a low and a high threshold, okay? So if we are filtering colors, and obviously, probably if we have a look at the answers provided by ChatGPT, we can also extract information from this, right? So let me have a look at this. Okay. Yeah. So under the code that ChatGPT provided to us here, yes, there are some tips, yeah, which I didn't read, but now it's the moment to have a look at this, yeah. For example, if your track is not black, you'll need to adjust lower black and upper black to match your track color in HSV. For example, yellow line. This is the example for a yellow line. This is the example for a white line. Yeah, you can use OpenCV or an image viewer to inspect the HSV values for toning. Let me know if you'd like to add logic to follow the track by controlling the robot based on the centroid, okay? So many things, ChatGPT is saying many things here, okay? But the important point in this case is this one, yeah? This is what some of you already said in the chat, yeah? So the problem here is that the values that we are using for filtering the track color, yeah? These ones are meant for black, for a black track, yeah? And our track is not black, right? It's kind of a gray color. Yeah, gray, blue, yeah, but it's definitely not black. And these values apply for black, yeah? So obviously they are not going to work for my track, right? Yeah? But here he's giving me some examples for yellow, white, not useful, neither, okay? Then the follow-up question, what's going to be? Yeah? So obviously the next question is, okay, so how can I get the HSV values for my specific track color, okay? And this is not obvious at all, right? This is not something that I'm going to ask here to the chat, hey, give me the values I need to use, the lower and upper thresholds I need to use in order to filter this specific track of this circuit, yeah? Can somebody answer me that right now? No, right? It's impossible, basically. That's something impossible to answer. Then that's another great field where ChatGPT can come in handy, can help us a lot, okay? Because otherwise, here, me personally, I would have a huge problem, yeah? Okay, then what can I do? So I'm going to ask ChatGPT to help me, right? How? Obviously, with another prompt, yeah? So I'm going to ask him directly, hey, how can I find the values I need for deciding the HSV range? Let's ask this directly to ChatGPT. How can I find the values I need for deciding the HSV range? Let's go. So this is the answer. Step by step, find HSV range for your track. Capture an image from the robot. Use your existing camera subscriber to save a frame. Add this line in your callback temporarily. Okay, so here it's giving me option number 1. another option. Use an HSV color picker tool. Option number 2. Online tools. Option number 3, set your HSV ranges. Okay. And then here it's giving me some options, right? You can see number 1, some options to do this. Number 2, number 3. I saw somebody in the chat also. Alexi says, capture image and pass it to the chat with the question. Yes, that would be another option. Yes, so we could, for example, get an image of the truck and pass it directly to ChatGPT. Yeah, that would be an option, okay? But we are going to do something even cooler, okay? Pay attention to the last line that ChatGPT is saying here, right? He says, do you want me to include a live HSV tuning graphical user interface with sliders in OpenCV so you can find the range interactively? Hell yes, I really want to do this, right? So I'm going to go for this approach, okay? Because in theory, this is going to allow me to be able to use sliders to fine-tune live the HSV values that I need. So this would be ideal, right? Then I'm going to ask him to give me this, yes? So I think I wrote, no, here, this is just the initial question, so I don't have the follow-up question. So I'm going to write this manually here on the fly. So, yes, give me the code for want me to include a live for the live with sliders. Okay, yeah. Yes, give me the code for the live HSV tuning GUI with sliders. Okay, so I'm going to ask him for the code. And there we go. So here we have this script. What it does, lets you adjust HSV ranges using sliders, shows a live preview of original image, binary mask, result of applying the mask. Okay, then let's copy directly the code from here, and I'm going to create a new script. This one, this is Python, it's nothing ROS related, so we can create the file directly here. For example, I'm going to name it hsv.py, okay? You can create this file wherever you want. And then here I'm going to paste the code, okay? So something to take into account is that this code needs an image, okay? It needs an image to be able to properly evaluate the HSV thresholds, right? So in this case, in the ROSJECT, I have included this image, fastbot_track PNG, you can see here, okay? There is an image that I already took from the track, and I have included here. So what I'm going to do is to update this line number 8, in my case, yes, actually it says exactly this in the comment of the code, replace with path to your captured frame, yeah? So here I'm going to change the name to the image that I have, yeah, which is fastbot_track.png, all right? fastbot_track.png. Okay, and then I'm going to directly run this program with Python, so Python 3 hsv.py, okay? There we go. Okay, so here I have a problem that I already faced during my tests, which is basically that the display is too big, right? This is too big, so I need to make it smaller. Then let me ask ChatGPT to make it smaller. You make the display smaller. It's too big. So let me get the updated code with the display a bit smaller. Then let me come in here, Control A, and replace the code. And I need again to update the image fastbot underscore track dot png. Okay, so let me rerun my program. There you go. Okay. So this is much better, and now probably I can even resize it. There you go. Okay, so let's tune these sliders and let's see what happens, okay? So as you can see, in the very left, here I have the original image, and here I can see with the masks applied, okay? So the goal would be to reach something like we have here in the notebook, you can see here, yeah? Where the track, the racing track, is isolated from the rest of the environment, right? Something like here, okay? So this is the goal that we want to achieve, so we can manually move the sliders like this to get more or less the result that we want, okay? Let me make this a bit bigger. Yeah, so this is kind of looking good. Let me also move this second slider. No, too much. Right, and then here also, no, here I'm starting to mess with the track. Okay, so something like this is more or less good, and also with the upper bounds, which, yeah, here they go away, so let's leave the values at something like this. Also here, yeah, we are going to leave all these values around here, and this has to be a bit bigger because as we go down, as you can see, the track fades, right? So we should keep this. Yeah, and then it's just a matter of playing a little bit with all these values, right? To get the optimal result and basically filter as much as you can the track, okay? It would be a matter of this, playing a little bit with the values, yeah, until you get the optimal result, okay? But as you can see, this tool is really, really convenient, right, for this kind of stuff, yeah? Then here I have something more or less that seems that could be interesting because I am filtering pretty well the track, yes, from the rest of the environment. So here, for example, the first HSV values are the lowest bounds. So this, in this case, it would be 97, 114, and 101. So let me try something like this in my code directly. So the lower bound is something around, wait, where do I have it? So 97, 114. So this is 97. This is 114, and this is 101. 101, okay. And for the upper ones, we have 131, right? So 131, 178, here 178, and 136. So these values are not going to be great because, as you can see, the image that we are using is a high resolution image, let's say, and the one that the robot is going to be using, it's much lower resolution. Yeah, it's something like this, the one that the robot gets. Yeah, okay. So some values like that we are using here, we might need to fine tune them more. Okay, but let's try something like this already. So let me recompile and try this updated code with the new values that we've gotten from our really cool HSV application. Let's run our code that we have recompiled. And we can see now a whole different story, right? So now the track is being properly detected, And I even have the centroid here right in the middle. Okay? Yes? So probably this can be still fine-tuned a little bit, but this is pretty good already, I would say, yes? Because I am properly detecting the contour of the racing track and I am properly extracting the centroid, yeah? So in a moment like this, with the help of ChatGPT, I have created an application that has helped me in a moment find the proper HSV values that I need for my application and for properly detecting the track. In a moment, yeah? Without ChatGPT, this would have been much more difficult and would have taken much more time, yes? And for me as a roboticist, it's not important, it's not worth to dedicate a lot of time finding the proper HSV values. I don't mind what are the numbers I need for that. What I want is to be able to filter out and detect properly my track, yeah? I don't mind if the number is 100 or 150. That's not important for me, yeah? So for that, I use ChatGPT. Tell me, solve me this problem. I don't care, okay? And as you can see, with the help of ChatGPT, we have been able to solve this real quick. Yes? Okay? Then, all right, so now we are able to properly detect the track. So what would be the last step? Yeah? Now we are in step number 5, which is repeat step 3, okay? So remember, step 3, what was it? Complete the details, yes? So we have so far completed one of the details, which is being able to detect the track. What is the next detail? Well, the next detail is to make the robot follow the track, right? By following the centroid, okay? Then for this, again, I'm going to use another prompt, which is right here. So update the image callback to send velocities to the robot based on the detected track centroid. So I'm going to use this prompt, which is very clear with the goal, yeah? I want you to update my image callback in order to send velocities to the robot based on the detected track centroid, yeah? So let's sell this. Compute the horizontal offset of the center from the image center. Use a simple proportional controller to generate angular velocities based on that offset, okay? And publish the corresponding twist message to make the robot follow the track. So here I have my updated callback. Yes. Actually, let me grab from my code the HSV values because I want to still use these ones. So I'm going to put them, I don't know, let me put them here in the meantime so that I don't lose them. And then now, yes, I'm going to copy the code, paste it to my callback. There we go. Remove, paste. Do I need to... what happened here? Wait. I want to copy just the try. Probably I need to fix the indentation here, right? Yes, there we go. Okay, so here we are, and then let me recover my thresholds that I have found earlier. There we go. Okay, so then let's now compile our code. Again, recompile. We have added the code generated by ChatGPT to generate our proportional controller, yeah? So here we can see how it's computing the error, yeah, from the centroid. It's generating the twist message. This is looking good so far. So I would assume that it could work. Then let's test it out. So source install setup bash. And let's run our program. And let's see what the robot does. Okay, so we can see that the robot starts moving. Here it's actually close there to the wall. So what I'm going to do is to move it a little bit like this. Okay. Let's leave the camera here. Okay, so there we go. We have our robot properly detecting the track, okay, with some errors there in the borders, but it's more or less detecting the track properly, generating the centroid, and as you can see, it's actually following pretty well the track, right? So it's doing here the turn to the right, which is expected, yes, and we could leave it here running for a few more time. Obviously, one of the things that we could do is to make it move a little bit faster, right? So, because right now it's moving too slow, but it's working, right? So it's detecting the track, and it's generating the centroid and properly following the center of the track, right? So, goal accomplished, okay? Probably it's not going to be the fastest one, but it's going to very likely be able to complete a full lap to the circuit, right? Yeah. I'm going to leave it here, trying to complete the lap. Okay. So let me go back to the chat to see. Pass it. Okay. Yeah. So anybody else has been able to complete the example as I have it here, with the robot properly detecting the track and following it? Anybody else has been able to reach this point? Any questions also? So this is the full example that I wanted to generate today. Oh, wait, I can see. Okay. Here we have some more. Okay. Back to my former question. At last, we must share ROSJECT to participate in the competition, right? I think it was written in the competition notebook. My question was about my problem with this issue. The share option does not exist. When I hit the 3 vertical dots, there are only 2 options: make it public and add ROSJECT to showcase. The make it public option is inactive. Okay. Let me have a look at this in a moment, Sajat. Alexis says right off the bat. Deepan says, can you show how to adjust PID gains? When you reach the first turn, the line following loses the centroid and goes off track. Yeah, well, here in my case, it's going well. So do you mean in your case, Deepan, it's losing track on the first on some of the turns? Okay, then I'm not sure if that is PID gains, right? Well, it depends on why it's losing. It loses the centroid, but if it loses the centroid, maybe it is because the track detection is not correct, right? So maybe you should fine-tune a little bit more your HSB thresholds. Okay, so that could be another reason. Actually, here we are not using a PID controller, but just a P controller. Okay, as you can see from the code, here we are using a proportional gain. Yes? Basically, what we are doing is to find, oh, there it's losing. There we go. There it lost, but this is a problem of the HSB, okay? This is not a problem of the PID gains. This is a problem of my HSB. See? It got confused with the line. So in this case, what I would need to do, let me rotate the robot back there. See? So here, because of the line, it gets a bit confused and it loses the centroid. See? But it's because of these blue and white lines here. See? It's not because of, so this is basically a problem with the HSB, not with the PID, okay? So for that, we will need to tune a little bit better let me move it past the finishing line. Where is my robot? Let me move it. If I go past this, it's going to continue working, see? So the issue in this case is that this specific part of the circuit, the starting line, has messed up my HSB filter in this case. So I will need to fine-tune a little bit better the lower and upper thresholds in my case. Okay. So for example, what I could do is to take a picture of that specific part of the circuit in order to see how to filter it out better, right? Yeah. But that actually is going to be homework for you, all right? Let me have a look at this. Okay, it is currently going back to the first position. Can you show when the robot goes to the first turn? Okay. Yeah, so here, in my case, the turns are working properly. You can see here the robot is properly turning to the left, see? So, yeah, no problem with the turn. ChatGPT answers are normally random. It is incredible that with your prompts, you managed to get answers that guided you more or less through the same workflow you had tested in advance. Yes, exactly. So that is something. So we have seen also in this class that some of the answers that it gave me are a bit different, but if you use the correct prompts, more or less the results are going to be very similar, yeah? But that is a matter of writing good prompts, okay? But very good observation, Anderson, yeah. This is actually another issue because when you reach near the finish line, the markings change, which cause the robot to lose track again. Yeah. Okay, all right, guys. So then what is going to be the homework for this class? Yeah. So the homework for this class is going to be actually two. Yeah, you are going to have to, I'm going to pass you two homeworks. First one is to be able to bypass this kind of issues like the one I just had with the starting line. Yeah. For example, there is another place where the track color is going to change, which is the tunnel. Okay. So down here, there is somewhere in the. I'm not going to go there because let me see if I can find it by zooming out. Yeah, I think it's right there. Yeah, right there. There is a tunnel, okay, or you can see it also here. Yeah, there is a tunnel where obviously the colors of the track are going to change, okay, because inside the tunnel is darker, so there are going to happen some problems similar to the problem I had in the starting line of the circuit, yes, where the HSB filter is going to lose the track, so it's going to not be able to properly generate the centroid, so my robot is going to not be able to properly follow the track, okay? So I want you to fix these kind of issues, okay, by yourself, and any others that you might find, okay? Also, maybe you can try increasing the speed and all this kind of stuff, yeah? So basically what I want you to do is to optimize the program, of course, using the help of ChatGPT, yeah? You can optimize the program so that the robot is going to be able to bypass. Here you can see the robot currently is reaching the tunnel area, in my case, yes. Then you should upgrade, improve the code that we have right now so that the robot is able to properly follow the track anywhere in the circuit without losing track, okay? Yeah, so that is the homework that I'm going to pass to you. Homework number one, and homework number two is in case that you want to send your code to our contest. Yes, so you can use the one that you generate here, pass it to the ROSJECT. So you can see there how the robot is starting to lose the centroid when it's getting to the tunnel area. See, exactly, you can see there exactly the issue that I was talking about, yeah? So, because here the track is changing because of the tunnel, the robot is losing its position and it's going to fall or whatever, yeah? So this is what, these kind of issues are the ones that you need to figure out and fix, okay? Yes? And now, right before finishing, okay, and then finally, if you want to use your code, obviously you can use it ROSJECT for the robot racing contest. Okay, let me have a very quick look. I'm going to stop my program already, and then let me have a quick look at the ROSJECT that was shared for the contest, which is this one here. Okay, so let me copy. Can I copy this? Okay, there we go. Yes, and then yeah, I'm just going to stop this, go back to my ROSJECT and copy the ROSJECT for the contest. Yes, so this is the one that you should use for the contest if you want, and then okay, yes, I can see here there is no yes, I can see what one of you were saying now. So here in this project there is no option to share it. Okay. So we will look into this. Who was saying it? I think it was Sajat. Okay, so I have seen what you were mentioning, Sajat. So don't worry, we will fix it, and then we are going to be able to share the project basically once you have it completed. Okay, so don't worry. Yes, so it's going to be same way how it is indicated here. Okay, here at the end. Yes, the thing is that now for some reason this is not appearing. Okay, but don't worry, we will get it fixed right now. Okay, so it's going to be exactly how it's explained. It's explained here. Will there be more than one robot on the circuit or just one robot? Only one robot during the race, Rajesh. Thank you, Deepan, for your comments. How long does it take to complete the circuit? That depends. That depends. So you just have to think that you need to be the fastest, Rajesh. So yeah, don't worry about others' times. Just focus on doing it, getting the fastest time you can. Okay. All right, so yes, then I'm going to leave it here for today. I hope that you have enjoyed the class, that all of you are going to work on improving this code that we have generated today to be able to get the fastest lap, and that you are going to use it for our contest. And yeah, I'm eager to see by the end of this month, by the end of July, who is going to be the winner and what is going to be his time and everything. So yeah, go ahead. And yes, so that's all for today. I hope that you have enjoyed this class. I hope that you can take something useful from it. And yeah, I will see you in the next one. And as always, until then, keep pushing your robotics learning. Bye-bye.